Okay, quick recap for Euler's method. Let's fill in the blanks on the statement that I left you guys with. Each new y value is gotten by taking it should be the old y value. Okay, we take the old y value and we add on whatever portion of the slope, and what I mean by whatever portion, I mean like double the slope or half the slope. The ones I did for you guys on the worksheet was half slope, and it should be of the slope. And it's at and I'm going to just say the old point, so it's the point that you're starting with that you need the slope at, not the point that you're trying to get. So at the old or initial point. I'm going to go with initial. Okay, let's see how this translates into math speak. So I said if the step size is h, then our new y, our y2, will be our old y, so our y1, plus whatever portion of the slope, okay, so that's the step size, how far we're moving along, times the slope at the previous point. Okay. All right, let me tape this out for you guys so it doesn't look so horrible. Honestly, I don't know if this looks much better, but this was the best I could do. So you have my sloppiness, and then you have this sloppiness. Okay, let's do an example. Okay, so sorry for this being a little sloppy, but y equals f of x is a solution to the differential equation dy dx equals y minus x. The point 51 is on the graph of the solution to this differential equation. Approximate f of 6 if Euler's method is used, starting at x equals 5 with a step size of 0.5. Okay, so I'm starting with the point 5, 1, which means my initial y value is 1. Okay, my new y is going to be the old y value. Okay, so 1 plus my step size, which they're saying is a half, times the slope at the point 5,1. And I find my slope using this differential equation. I do y value minus x value. Okay, so I'm using this x and y value. All right, and so I'm going to be doing 1 minus 5 for that. Okay, so I have 1 plus a half times negative 4, which is 1 minus 2, or negative 1. Okay, let's talk about what the new point is. All right, my new y value is easy to see. We just figured out it's negative 1. What is the new x value? Well, I started at x equals 5, and I just move over how far? I moved over half a unit, so now I'm at 5.5. Okay, so now my new y is going to be my old y, which is negative 1, plus a half, which is my step size, times the slope at the old, or the initial point, okay, which is this point here now. Okay, so I do my slope by doing my y value minus my x value, so negative 1 minus 5.5. Okay, and that is going to give me negative 4.25 as my value. Okay, so it's a very easy formula to use, and I'm hoping that you guys understand from your worksheet why the formula is what it is, and if you feel like you're not comfortable with it, then we'll hash it out whenever we have class together again. Okay, here's another example. This is actually from your blue book, and it doesn't say enough. It doesn't say to use Euler's method. It doesn't say what kind of step size to use, but we're going to use Euler's method with a step size of a half, and we're going to do this. So after seeing that last problem, I would say pause it, try it, and then come back to me. Okay, I'm starting at the point 1, 3. Okay, so my initial y value is going to be 3. Okay, and again, they don't say what step size to use, or they would tell you to use Euler's method twice maybe, but I'm going to say just use a step size of half. We're going to do Euler's method twice because that's what you're going to be asked to do on the AP exam, and I'm going to find my new y by taking my old y and then taking a portion of the slope, so step size times slope, and I find the slope on this one by doing x times y minus y squared. So I'm using this coordinate, okay, and I'm doing x times y, so 1 times 3 minus 3 squared. So that's going to give me, I'll have my 3 minus my 9, negative 6. Half of negative 6 is negative 3. 3 plus negative 3 is 0. Okay, I want to talk about what the new point is. Okay, the y coordinate on the new point is obviously 0, but what is the x coordinate? Well, I started at x equals 1. Okay, I started at x equals 1. I just move over half a unit, so now my new x-coordinate is 1.5. Okay, so now my new y is going to be my old y plus the portion of my slope. So the step size times the slope at this point. So I'm going to do x times y minus y squared. Okay, and I'm just going to get big fat old 0 here, and 0 plus 0 is 0. So that would be my approximation. Okay, a little bit of letdown. The numbers are easy, but the process on Euler's method is great. It's easy. It's a nice, cute little formula. I'm hoping that from the packet that you guys got a good understanding of why that formula is, and I'm hoping that that formula sticks with you instead of it being something that you can't remember.